Hi everybody, today we're going to go over some old factoring and introduce some new styles of factoring. Very first thing you always check for is the greatest common factor. So no matter what, it's not always there, but you do always have to look for it. So we're looking for the highest number that will divide evenly into the numbers and the power. So even though it's called the greatest common factor, we're looking for the lowest power. So if you have to choose between the two, like we do here, we have a to the third and a squared, you pick the smaller power. So we definitely are taking out an a squared. Now the numbers, they're both even, and it doesn't seem like 4 or 5 or anything else will go into both, so we're just going to take out a 2a squared. So even though we're factoring, we're really dividing. So when we factor, we keep what we divide, we just write it out in front. So 12 divided by 2 is 6. And if we have a to the third and took out a squared, that's an a. And you start over, 10 divided by 2 is 5, and all the a's are on the outside. So here, in number 2, we have a lot of letters. So we have m, a power of 8, and a power of 2. So we have to go with m squared. N is to the power of 5 or the power of 2, so we have to, again, go with the smallest one. Now, for the numbers, 14 and 7 divides evenly into both of them. So then we divide. 14 divided by 7, that's a 2. Subtract your powers. So we have m to the 8th, we took 2 out, so this is m to the 6th. And then n to the 3rd, because 5 minus 2. The minus sign stays there. Now remember, 7 divided by 7, that's a 1. So we know our number is a 1. And then all the letters, they're all on the outside. So we just keep that minus 1 there. So don't forget the ones. It's very important. So then when we use distributive property, we could end up back where we started. The next style we're going to go over is the difference of two squares. And the name really is descriptive. It has to be a minus, and it's a perfect square minus a perfect square. Some perfect squares. Let's make a list of numbers. But just before you forget, any even power on your letters, these are perfect squares. So any even power, even though it might not be a perfect square, like x to the 6th. I know 6 isn't a perfect square, but it can be broken down into x to the 3rd times x to the 3rd. So any even power is going to be considered a perfect square. The numbers, 1 squared is 1, then 2 squared, 3 squared is 9, 4 squared, 5 squared, of course, is 25, and then 6 squared. So these are the numbers we're looking for, just to kind of give you an idea. Don't forget about some other ones, like 10 squared is 100, 11 squared is 121, 12 squared is 144. Some of those larger numbers we'll see as well. So just to kind of give you an idea is what we're looking for. So in number 3, what's going to start to happen is we're going to start to combine these two methods, greatest common factor and the difference of two squares. Now that we've kind of already done factoring, you'll see that it just gets a tiny bit more complicated. We start using more than one rule. So they both have a 2 in common. That's it, because this is kind of a dead end. So 72 divided by 2 is 36, c to the 4th, and then 2 divided by 2 is a 1. Now the 2 stays there, and 36, that's a perfect square. C to the 4th is an even power. That's a perfect square, and 1's a perfect square. So the difference of two squares, you're basically taking the square root of the first term, so that would be 6c squared, 6c squared. Then we're taking the square root of the second term, 1 and 1. And then your signs, 1 is a plus, 1 is a minus. So let's try this again. The numbers that they have in common is just a 7, and then the letters. We have to pick the smallest power, so that's going to be x, y. Now when we divide this out, we end up with x to the 6th minus 4 y squared. Again, even powers are perfect squares. 4 is a perfect square. 7xy stays out here. So x to the 6th, when you're taking the square root, you basically just split it up evenly. X to the 3rd, x to the 3rd. 4, the square root of that is 2. And then for the y squared, it would just be y and y. Again, one gets a plus, one gets a minus. The plus and minus order doesn't matter. In number 5, you can see they're both 10. So 10 is definitely coming out. The lowest power is an x. So when we take this out, 10 divided by 10 is a 1, but there's still an x to the 4th. And 10x divided by 10x, that's also a 1. Oops, I'm not sure what I'm writing there. Sorry, this is 10x. And so then we take x to the fourth. That makes this x squared and x squared. Square root of 1 is 1 and 1. 1 gets a plus, 1 gets a minus. Now what's weird about this is this guy right here gets factored again. So we're not done. So the 10x is there. The x squared plus 1 is there. And then the minus turns into x times x, 1 times 1 plus minus. So that's what you can start to expect, is that things just take a little bit longer to factor because you have to multiple times factor it. Now here's a new one. And these two are the same. They follow the same rule. So with this, the difference of two squares, it matters that it's a minus. When we have two cubes, the order doesn't matter. Or I mean, the sign doesn't matter. The order doesn't matter either, but the sign also doesn't matter. So it can either be an adding or a subtracting problem. So let's start off with some perfect cubes. These are going to be numbers that maybe you're not as familiar with. 1 to the third is 1. So again, we're dealing with like 2 to the third, 3 to the third, those kind of numbers. So 2 to the third is 8, then 27. 4 to the third is 64. 5 to the third, we'll see this one a lot, 125. 6 to the third is actually 216. And 7 to the third is 343. We generally don't go much higher than that. Just looking around, you can see we will probably stick to the smaller ones. So that's how it's going to go. Now, how we do this is we're thinking about cube roots. So what number times itself 3 times gives you a to the third? So we have a to the third and b to the third. The way we're going to factor this, it has to be memorized because there's no other way to do it. So it's really going to force you to sort of memorize this. So the cube root, what times itself 3 times gives you a to the third? Well, that's a. What times itself 3 times gives you b to the third? Well, that's b. So we're done with that one. We're going to do the signs last. Then you take the first term, and that's this one, and we square it, and that goes here, a squared. Then you multiply these two things together, ab, and then you square the second term, square the b. And notice I left a lot of space because the signs will be same, opposite, always positive. So same, opposite, and always positive. So it spells out the word soap because it's so clean when we factor it. You just factor it once and it'll be done every time. So same, which is a plus, opposite to that, minus, always positive. We're obviously going to run through this several times, so let's do this again. So again, we're thinking cube roots. So what times itself 3 times gives you x to the third. And then we're also thinking the cube root of 27. Well, the cube root of 27 I have on my list is 3. Second group is a trinomial. Square the x, multiply them together, square the 3. Signs, same as the original, opposite to that one, always positive. Notice I did my signs last. I would suggest you do the same. Here, we got a greatest, no we don't, that's an n, sorry. So m to the third, what times itself 3 times will give you that? That's m. And then 216, because it's in my list, here it is, it's a 6. Oh, and then we have the n at the end as well. Square the m. Just multiply these together, don't do anything fancy. So 6mn, and then square the 6n. So that's 36n squared. Signs go same, opposite, always positive. For number 9, these are not my perfect cube list. So they have a greatest common factor. 4 goes into both of them. 500 divided by 4 is 125, and then a to the third is still there. And 4 divided by 4 is 1. So now we have the perfect cubes again. So 4 stays there. 2 terms, 3 terms. That's how this always works. Cube root of 125. That's a 5. And the a is still there. Cube root of 1 is 1. Square the 5a, 25a squared. Multiply them together, square the 1. Signs go same, opposite, always positive at the end. For number 10. What do they have in common? Let's see. 4 doesn't work, 5 doesn't work, 3. 3 works, so we have 3. Then we're looking at the lowest power, so that has to be a C and a D. So this is going to be 8c to the third plus 125 d to the third. So when we have letters in the front and the back and numbers, it doesn't change anything. So the 3cd stays here. Cube root of 8 is 2 and c. Cube root of 125 is 5, and then of course we have a d. Square the 2c, that's 4c squared. Multiply these two things together, 10cd. And then of course, square the 5d. That's going to be, sorry, I'm trying to find a pen here, 25d squared. Signs go same, opposite, always positive. Now, if there's a minus sign, it's exactly the same. So if we have a to the third minus b to the third, we do the exact same thing. Cube root, we get a. Cube root, we get b. Then we square the a, multiply them together, a, b, square the b, b squared. Signs are the same pattern. Same, opposite, always positive. It's the exact same pattern. We just have different plus and minus signs. So again, we're going to do cube root of x to the third, rather, and cube root of 1. Square the x, multiply them together, square the 1. Same as the original, opposite to the one you just wrote down, always positive. Since this is so much the same, I don't know that we need to do all of these. Let's do number 13 because it's backwards. I know sometimes you like to have the number first. Here we have 4 and 32. Ooh, they're not perfect cubes, but 4 divides evenly into both of them. 1 minus 8h cubed. So 4 stays here. We have 1, 2h. Square the 1, multiply these two together, and then square the 2h. Signs go same as the original, opposite to that, always positive. Quick review of trinomials. This is old stuff. Don't want you to forget. Now remember, things are going to start to get kind of put together. We might expect difference of 2 squares, expect some difference of 2 cubes. It really could be anywhere. So just as a reminder, we multiply to get to this number. That's how we start. That's how we make our choices. So our choices right now are just 1 times 1. And then you add or subtract to get to the middle number. So 1 times 1 is 1, and 1 plus 1 is 2. So we know that the choices are very limited. It has to be 1 and 1. In order to get x squared, it's x and x. Or to make that a positive 2, they're both positive. In number 16, look for a greatest common factor. Always do it first. These all have an x in common. So we have x to the fourth minus 24x squared minus 25. Now we're looking at factors of 25. So in order to multiply to get 25, we have 5 times 5. That's going to add up to give you 10. We don't want that. And we also have 1 times 25. This adds up to give you 26, but it also subtracts to get you 24. So it looks like 1 and 25 are the winners. So let's figure out what we're doing here. X to the fourth splits into x squared and x squared. You just divide it up evenly. So we know we have a 25 and a 1. We want the 24 to be negative, so the 25 is negative and the 1 is positive, because negative 25 plus 1 is negative 24. The problem with the plus sign doesn't factor, but the minus sign is the difference of 2 squares. 25 is a perfect square, x squared is a perfect square. So you got to pay attention and look for all of the things. Let's try 17, greatest common factor. You can tell because it sticks out at the end there. Also, when we start with x to the third, it's difficult, so look for taking that out. We want an even power generally first. So we have x squared plus x minus 20. Generate your choices for 20. So multiply to get 20, add or subtract to get 1. 2 times 10, that's a 12 or an 8. That's no good. 1 times 20, 4 times 5. So we need, what do we need? A positive 5 and a negative 4. So the x stays out there, and we already know the numbers. We did all the thinking. And we're done. For number 18, don't forget this. What's your process here? Are you going to slide and multiply and then divide by a? Are you just going to go for it? Try to figure it out by guessing and checking? Only one way to get the 3 is 3 times 1. Only one way to get x to the 4th when we do this is x squared and x squared. Now there's only one way to get 5, but we can't determine this by the middle. So in order to get to 14, I'm going to put the 5 way out here. This is going to give me 15. Of course, the x squared is there. Put the 1 in here. This is 1x squared. In order to make this 14, I want it to be 15 minus 1. So I know the 1's negative and this is positive. And neither one of those factor again. Now the last style we have is if you happen to have 4 terms. 4 terms is grouping. It gives itself away. So we don't have to think too much about it. It is grouping. And when you group, this is what we mean. Here's the words. But we're going to take and group these two, and then we're going to take and group these two. The sign of that third term is part of the third term, so that's a negative 4x. And when we group those, you're asking yourself, greatest common factor, right? That's what this is. Greatest common factor for the first two, just the first two. They both have an x squared in common, so then we're left with x plus 1. Then you look at the second two. It's like it's a whole nother problem. It's like it's a completely different problem in the problem. They both have a negative 4 in common. And here's a hint. When it starts with that negative sign, you got to take out the negative sign. So they have a negative 4 in common. And what we have left is x. Negative 4 divided by negative 4 is a positive 1. Now what is supposed to happen is these match. If they don't, then you possibly have done it incorrectly. Now what's kind of nice about this, this is now our greatest common factor. So that's going to come out. And then you just write it in order, x squared minus 4. Now, of course, you wouldn't think I'd give you an easy one this first time. This is the difference of two squares, x minus 2, x plus 2. You got to keep looking for the difference of two squares. It's going to pop up everywhere. So let's try some of these. Again, you can tell it's grouping because you have you have 4 terms. We group them like this, first two, second two. First two have an x squared in common. The second two have a 9 in common. And we just divide. The x minus 1, that matches, so one of them comes out. It's just greatest common factor again. Then you just write what's left in order from left to right, x squared plus 9. What's left over gets its own parentheses. Number 20, group, group. So the first two have an x squared in common. Now again, here it is. When it starts with that minus sign, you got to bring out the minus, and they don't have anything in common. So this is kind of a weird factoring move right here. It's kind of unique to grouping. We're actually just going to factor out that negative sign, or the negative 1. So that leaves you with x plus 5. We are absolutely forcing these two things to match. So you kind of have to sometimes factor out a negative 1. Now again, the x plus 5's match, so we write that once. And then you go in order from left to right, and in the second group, it's x squared minus 1. That's why the sign matters, because the sign goes in there. And, of course, x squared minus 1 is the difference of two squares, x minus 1, x plus 1. I'm going to skip 21. This is the same. Take a look at 22. This one is different from the rest. First two, second two. First two have 2 x to the 4th in common. Right, because we've got to go with the lowest power. That leaves you with x minus 9. The second two, 7 and 63, they have a positive 7 in common, which leaves you with x minus 9. X minus 9's match, so you write that once. In order from left to right, 2x to the 4th plus 7. So you have some homework problems to try for 17-1. They're kind of all mixed together. Look for the 4 terms. That'll be grouping every time.